Okay, let's have another go at another type of question. Now, this is an annuities question for superannuation. It is a little bit of an easier question because some things are broken down for you. And this is actually from a 2010 HSC paper, question 9A. Now, I'm only doing the first part because I just want to show a certain skill that is kind of in some questions but not others. And I'm not entirely sure why it's in some and not others, but it's something that is a little tiny little trick that happens when proving annuities can cause students to trip up a little bit. So what's happening here is I'm going to try and prove, sorry, I'll sort of read the question. When Chris started a new job, $500 was deposited into his superannuation fund, so there's annuities, at the beginning of each month. The money was invested at 0.5% per month, so our job is done for us, compounded monthly. Beautiful. So they've done the work for us there. Let P dollars, or dollar P's, be the value of the investment after 240 months. When Chris retires, show that the P is 232, so 232,175 and 55 cents. Okay, let's do this. So, because they've always done the work for us here, they're saying that each month it's going to be 0.05. And we also need to put our 100% on that, so it's going to be 0.005. And it's compounded monthly. So they've actually done the work for us. They more want us to prove. They want to see our understanding. And a lot of HSC questions are like this in the sense of they give you the answer and they go, okay, prove it. Do you understand what you're doing? I don't know if it's a good thing or a bad thing that they do this. It's just a different style. It just demonstrates an understanding, I guess, without having the stress of finding the answer. It's here nor there. I guess it's a different style of question. But let's go through it. So in his first paycheck or first value of his investment, or first payment, let's go with that. It's going to be 500 times 100% times 0.05. Now, what this is, just to make sure, is that is 0.5%. So if we were writing this out as a decimal, this would be 0.005, not 0.05. It's not 5%, it's 0.5%, so it's going down further. So if we're writing that with a 100, which is going to accumulate that, it's going to go up. So just in our first one, and because they're putting it at the beginning of the month, we need to do this. Sorry, that's very important. The reason that it's not just 500 for P1, if they were putting it at the end of the month, it would be, but because they're putting it at the beginning of the month, that is developing an interest on it. And just to see how much this is, just out of curiosity, it's going to be 1.00, whoops, too many zeros, a very small amount, just like $2.50. Okay, so it's going up very, very, very small. However, if we do this for 240 months, what's that? 20 years, it's going to grow to this amount. So, if we put in P2, it's going to have whatever we had in P1 times our rate plus our 500 times our rate. So what this is accumulating for what was ever previously in there, and which is just 1 month at this point, but that's important for later on. And this is the 500 they put at the beginning of that month, which is separate. And if we expand that, we will get, taking from P1, 500 times, it's going to be that times that. I'll go a little bit slower for you guys. That's our P1 just here, times 1.005 plus 500 times 1.005. Okay, and if we expand that just here, so that times that, we are just going to make this squared because there's two sections of them. 500 times, I just like brackets, so I'm going to put in brackets, plus 500 times 1.005. Now, we can start to see a pattern, even in our second payment, that is going to give us these common factors of 500 times our rate. And it's going to be, the first one's going to be the same number as the month. And just to make sure we can do it for 3, it's going to look like this. I'll bring this up just a pinch. Okay, so we're going to have something that looks like this for our third payment. And that is expanding from P2 just here. This would just be the third month's installment. This would be our P2 times the rate, and if we expanded it, just like we did here, we would end up with this. Okay, that's what this represents. And over time, this is going to accrue until we get all the way down to P240, which is going to look pretty big. I don't think we can fit 240 calculations in here, so we'll just kind of make it a little bit easier. But just so you understand, that is exactly what we're doing. Let's just go to 0.239 plus ... all the way down till we get just this one here, which would be the 240th installment of $500. And do we close brackets? No. We will... No, actually, that's correct. Now, something we want to do here is we want to put it all in terms of 500. So our common factor here is 500, but we're just going to put all the 500 out the front, just for now. And we're going to put in this one to the front. And what would happen here is we would always go all the way up to 240. So we'd have something like this, okay? If we were rearranging this formula and putting this one first and second, third, all the way up to 240, we have 500 times all those increment rates. Okay, where do we go from here? Well, you can probably see just here, there's a kind of a sum of a geometric series here. It's going up, being times by the same rate, the same common ratio here of the actual rate that we have there. And our first one is going to be our actual rate. This can be a little bit confusing to begin with because our initial is also our rate. And some people get a little bit confused. Now, previous example, 1 was our initial, and we're times by that. The reason why this works out is because our rate is applied to the beginning of each month, and that's kind of affects how the question plays out. So, if we're looking at this, and we're trying to do our sum of, it's going to be, A will be our 1.005, and our Rn will be 1.005. And from here, we can put it into our sum of formula, but our sum of formula will also be times 500. So whatever is going to be accruing here, in terms of how it looks, will be times by our deposited amount. So if we're going to put this in, it would be, let's stick to 240. It's going to be 500 times, let's do a big bracket, our A, which is going to be 1.005, times our rate again. Let's put that to 240 minus 1 all over. Let's do a bracket here. 1 point. Yeah, I'll leave it for now. That's how I do it in a calculator. 1.005 minus 1, close bracket, and close bracket. So here, we're going to be proving what happens. And now, this is the part I want to just quickly address. Because if we put this in our calculator, we will get our answer, okay, quite easily. But there is something that happens here that I want to address. And this gets a little bit odd in the sense of why they choose to answer it this way. But sometimes with these proving questions, they do this. Just to make it clear, I just want to calculate this part here. Okay, if I go 1.005 minus 1, I end up with 1 over 200. And the fact that it presents itself as a fraction is important. And I just quickly want to recall, if we're dividing one fraction over another, or one fraction divided by another fraction, a way we can solve that is switching the second fraction and multiplying each other. And this is what happens here, just in case you've forgotten. Let's say if I have, I'm going to use algebra here, b over, let's think of this, 1 over 5. Okay? Another way of writing that could be, we can say this is b over 1 divided by 1 over 5. Okay, and see, b over 1 is just b, but we're kind of writing it as a fraction here. And if we've got something like this, it's going to be b over 1 times 5 over 1. So if we flip this second fraction, we can multiply, which would be 5b over 1, which is just going to be 5b. Now, what's going to happen here is we're going to use this skill here. And this part here is presented, even though it could be like this, it's presented as a fraction. So we could put all this over 1 divided by this fraction. It's like, okay. And then what's going to happen is we're going to take that, which is flipped around, it's going to be 200 over 1, and multiply it by our 500. I'm just going to do it as slowly as possible so we can try and keep track, because I think this is a very odd move, but with these proving questions, you need to find why they do this. If you just want the answer, that's easy peasy, but I want to just make sure it's clear what they're doing. Okay, so I'm going to write this part as 1 over 200, and I'm just going to put all this over 1, and I'm going to leave this 500 the same. So P 240 equals 500 times. I'm going to put all this over 1, and just to be safe, I'm going to put it in brackets. 1.005 times 1. Oh, why did I write it there? I'm just going to bring it down. Sorry about that, guys. P240 equals 500 times 1.005 times, where's my bracket? 1.005, close bracket, 240 minus 1, close bracket, all over 1. All over again. Another fraction, and this looks ugly. Over 1 over, whoops, 200. Okay, now keeping with the same convention, if I've got a fraction divided by another fraction, really that's coming back to here. Okay, we can write it in this form. It's like this here, but we can also write it like this. So we can flip our second fraction and times it by this. Okay, so what's happening here, just going to make it a little bit clearer, 500 times, I'm just going to go over the one extra step just so people are not confused. How can I fix this up? That's fine. Sorry, that's messy. I should start again. I want to make sure it's clear. 1.005 times 1.005 240 minus 1 all over 1 divided by 1 over 200. And now, here's the part where we're flipping this part. Okay? So, it becomes 500 times this over 1 is just itself. So really, we can get rid of it. I'll leave it for now just to make sure that people understand. I'm just going to get rid of these brackets because now they're starting to annoy me. Times 200 over 1. Now, this is the part where it gets a little bit confusing. Well, not really. I can't go on to the confusing bit. They go 200, and they can't skip this part. And because these are all times, they go 200 times 500. Okay, and remember 200 over 1 is just 200. And so what's it going to give us? 500 times 200, it's going to give us 100,000. So what this actually becomes is this. Okay, so I do just want to stress that the beginning part here, if you had put this in your calculator, we would have proven our answer of 232,175.55 cents, and that is fine. That's totally fine. But some of the questions, and they do this, say, especially the proving questions, don't necessarily give you the answer, but give you a formula. And sometimes they get rid of this denominator, and it becomes a number at the front. And it's very confusing as to why they did that. They are using this simple fraction divided by a fraction kind of mumbo jumbo, where they're putting 1 underneath it and changing this to 1 over 200 in this case into a fraction. Okay, and they're using this transformation to get this number out the front. Okay, and then leaving the top. It can seem a little confusing, and I need you guys to understand how to do this in order to do your HSC, because some of the questions in your HSC say prove this, and my students at the moment can get to here and then just buckle and just don't know what the next step is. It's a simple idea, and it would be very stressful in an exam to try and recall this, but you just need to know how to do this, and it is kind of very important. I hope that's a good explanation of how I came to it, but really this is kind of year 8 mathematics with fractions. Okay, I hope that was helpful. If not, you can just write in the comments, and hopefully I can do a better job next time.